Okay, I think we start now lah. Good afternoon, everyone. Okay, from 4 students, this is a second group or Wednesday groups of from 4 lah. Okay, nice to meet you again today now. And I hope everybody doing fine in school. You enjoy your study in school and at home, doing fine and also healthy. Most important must be healthy everybody. Okay. Before I start the lesson, I would like to tell everyone something. Starting next week, the tuition will be held in a center. So you have to come to the center already. Okay? So meaning that the tuition will be only held in center, face to face and all. So no more online lesson, no more online tuition. So when I start tuition center, when I open already, means I will stop the online class Okay. You got problem or not? Everyone, got problem to go there or not? Still remember where is the center? Remember or not? Okay. You know why I want to open the center? Because I prefer teaching you all face to face lah. It's better, More because like after about 3 months, 4 months of online lesson, I noticed that it's not so effective lah. You know why I say not so effective? Because half of you when I call your name, you were not there one, You never answer me. Then I don't know you are there or you are walk away, just let the handphone or computer on only. That means you are not paying attention, half of you lah. Another half is good. Every time I call your name, you were there to answer question. So meaning that you are paying attention lah. That is very good. That one is very good lah. But I want to teach the whole group, not only half of the student. That's why I decided to open the tuition center. So starting next week onwards, all the tuition classes will be held in the center lah. So the time follow the previous time, 7:15 to 9:45. Okay, 7:15 to 9:45. And as usual lah, you only need to come with certain few foolscap paper, and all the handout or the notes will be forwarded and then will be given. You don't need to print out anymore. Don't need. All the exercises notes will be provided, will be given. Because I want to make sure when I teach you face to face, right? Make sure everybody have the paper in front of you. You must have the paper and then you must write on the paper. Then only effective one, I have the impression that when during the tuitions are face-to-face tuition, right? 70% of students when I call your name, you can answer question one. You can answer question one, you pay attention. But online, online lesson is only less than half of the student when I call your name, you can answer one. Less than half. The rest I call, no sound, no response, don't know where are you. So I think it's a time to go back to the center already. Okay, you all don't need to worry. Just need to wear a face mask to come. That's all. Okay, you need to wear a face mask to come. So the sitting position will be strictly at least 1 meter away from each other. Don't worry. Don't worry about social distancing. Okay, so you won't be sitting too close one. Okay, so before this, I think you also know that 1 row of table chair, you can sit until 9 or 10 students in 1 row before this. But after this, next week when you come, the most 1 row can put in 4 to 5 students only. So meaning that can fit in less student already. Okay, less student. So I hope everybody will follow your schedule lah. If you are Monday group, you come on Monday. If you are Wednesday group, you come on Wednesday group. Okay? Understand now? Okay? So basically, I will have to check your temperature. When you come in, I check your temperature. Okay? I will ask you to record your name, your phone number, and your body temperature. Either by using your handphone, you scan the QR code, then you type your name, your phone number, and your temperature. That's all, 3 things you need. If you don't have a handphone to scan the QR code, right, you can write on a box. Inside the box, you can jot down your name, your phone number, and also your temperature. Okay? All this I have to do. I have to follow follow the SOP. Okay? Another things no food, don't eat in the center. You can drink water, that one I allow but no eating already. Don't bring food to eat. No eating. And also the toilet. Before this, I did not control. You all know how many of you go to toilet. I did not control. But starting next week, I will only allow 2 persons at one time to go to toilet. Only 2. Okay? Then 2 persons go in, then the 2 persons came out already, then the next only can go. So at one time, only 2 persons can go to toilet. Okay? So, okay, any question to ask or not before I start lesson? I consider so many aspects already, so at the end, I make up my mind to open. I have to open already because when I look at online lesson, only at the beginning, most of you get very excited. Call your name, you can answer. Call your name. You answer question. Then after 1 month, 2 months, I think getting more and more difficult to call you to answer question already. Maybe you have the problem, you don't have the paper with you. You did not print out the paper due to certain reason. I know you don't have printer at home. Maybe you don't have the paper, and maybe some of you don't have a laptop. Okay, maybe your laptop is belong to your parents, so your parents want to use, so you don't have a laptop to use. Okay, right? So you cannot see the screen. I mean, what I explain through the screen, you cannot see. So it make it not effective at all, Okay. And another one is you don't have many of you don't have the microphone to answer question. Okay. It seems like when I call your name, so disappear, no sound. So all these will make the lesson less effective. That's why I decided go back to the center. The best is still face to face. Okay, I can look at you. I can make sure you have the paper. Make sure you write, you copy down, you jot the answer, you copy the notes. And I can make sure when I call you, you answer the question. That's most important. Yeah. Okay, come. Now, come back to our lesson. Last week, we started this refraction, not FRAC, refractions. Okay, come look at the paper now. I share the paper with you all. Okay. The title is refraction, right? Last lesson, we started this, I think 2 weeks ago, okay? Refractions of waves. So you already know what is refraction, right? So we have discussed refractions of water wave. You see the water wave will refract like this, isn't it? Then after that, followed by refractions of light. Light also, reflection of light. Example, you see like this law, reflection of light, correct not? Okay. Okay. Then also we have discussed refractions of light is like that, you see. Then followed by refractions of sound wave. Not use a balloon to explain one. Okay, refraction of sound. Okay, and also I think I already explained this diagram, right? Why when you put a balloon here, the sound become louder, refraction of sound, right? And after that, we have start answer some of question. Okay, now I want to know which question we stopped the other day. Juling, can you tell me we stop at which question? Number 5, number 6, number 7? Yeah, Juling.
We finish at 12. The 12 question we already finished.
1 to 12 finish already lah.
Yeah.
So now?
13.
Now 13. Okay, good. Thank you, Juling. Julie is one of the good students now. Every time I call her name, she will be around one. She never miss one, you know. Every time I call her, she will be around. She's very attentive, good now. But I want to teach the whole class, to want to teach us a parts of the student, so it's not fair to others, you know. Okay, come question 13. An observer cannot see the coin. I see when no water here, this observer can't see the coin because this glass is blocking. This person can only see the coin when you put water inside. So when you pour water, then what happened was like this, you know, you see the diagram. When you add water inside the glass containing the coin, right? So the light actually moving from the coin towards your eyes, you know. When you see something, mean the light go into your eyes. So what happened is the light from the coin go up, from the water go into the air, right? Tensor to less than. So it will refract away from the normal. This is the normal light. So you bend away, bend down. Tensor to less than is refracted away from the normal. So it bend down. But your eyes always see in a straight line. So when you see straight line means you see the image of the coin actually is here. The size become higher already, so this person can see the coin then. Okay, it's because of refraction. So when you see in a straight line, so the shadow, the image of the coin to be here already, so become higher, nearer to the surface of the water. Because of this, the person can see the coin, the image of the coin. This person actually only see the image of the coin, not the actual coin. Actual coin is still here, no? Okay, so the answer is refraction. Can you take down the diagram? This diagram is important that you must know how to draw. Everyone very sad already. So after I told you, need to go back to the center, so feel very sad. But never mind. You can use to it slowly. Copy the diagram, copy how the light go, okay? I have the impression every time when I teach online, I talk to the wall. Nobody listen to me. That's why sometimes I feel very disappointed. I only talk to the screen only. I don't know whether you listen or not. So sometimes I sit down, I think I feel very disappointed. Student, when I call, not there to answer, no sound. That's why I decided to open the center. Okay, go back to the center. It's the best way to see students face to face, one by one, to see them. Okay. I hope you all agree to go back to the center. Okay. In terms of COVID-19, don't need to worry so much already. Actually, now it's only a bit serious. It's in Sabah, Sarawak, not in Malacca. Malacca actually zero case for long times already. No case in Malacca already. Most important, when you leave your house, you wear a mask. Then guarantee no problem. Don't worry. Okay, wear a mask. Yeah. Question 14. A light travel from P to Q. Which of the following diagram correctly show? You see, Dong Chao Yi said D. Okay, Dong Chao Yi. Okay, later see your answer. P is tensor. Q is less than. Mean moving from tensor to less than. Zhong Zhao Yi answer D. See whether correct or not. Yes, correct. Zhao Yi, well done. So the answer is D. Why is D length? Because from tensor to less than. Tensor to less than is bent away from the normal. This is a normal. Okay. So it's refracted away from the normal. Move away from the normal lah. So it's bent here. So this diagram is correct. Okay. D, from tensor to less than, so it's moving away from the normal. You must identify the normal. Normal is here. So it move away. Okay. Okay, number 15. Sound of moving train at a distance clearer at night. You can hear the sound of the train clearer at night. This is because of what? Last week I told you, right? When you are singing at night, your neighbor can hear your singing. Okay? Nighttime, your neighbor can hear your voice clearly compared to daytime. Okay? So this is because of what effect? Susin, what effect next, Susin? Number 15.
Wait, sir.
Okay, never mind. I wait for you. Train at a distance clearer at night. This is due to the effect of what? Can or not?
Refraction B.
Yes, correct. Very good. Susin? Yes, the answer is refraction. Okay. B. Okay. The sound refracted at night, it go up and then it bend down to the ground. That's why your neighbor can hear your voice because the sound travel go up to the sky and then it come down it bend down to the earth. That was happened in the night. This one is refraction. Okay, number 16. This diagram shows the refraction of sound at night. I just said it just now. This diagram shows the sound travel at night. This diagram is correct. Eileen, 16 now. You have the paper or not? Which diagram is correct?
D.
Yes, correct. D. Sound go down. But remember, no, at night, the A near the land is cold. Higher up, the A is warm. Beside the sound will bend down. Okay? It travel up and then it refract, so it come down. Okay? Okay, this one is night time. Then this diagram show the sound during the daytime. You make a note here. D answer is for night time. What about daytime? Daytime, which diagram is correct? If daytime, which diagram is correct? Sima, if daytime, which diagram is correct? Okay, someone answer here. Zhong Zhao Yi say A. Yes, Zhong Zhao Yi, you are absolutely correct. A. I said, please make note. This is daytime. A is daytime. Daytime, the sound bend up, go up one, not come down, go up. Nighttime, it come down. Daytime, it go up. But daytime, the A near the land is hot because land is hot at daytime. Up here, cold. That's why the direction bending is different because here is warm. Up here become cold daytime. Nighttime, the ballet. Okay? Yeah. All these are because of refraction, Yeah. So I cannot see your face. So that's why I cannot simply call in. If center face to face, I can see your face. I can simply just speak and then call you. To wake you up so that to remind you to focus. Here cannot. Here I talk to the wall, talk to the screen. I shock sendiri. Ngu you tong. I always talk to the screen. I shop sendiri, you know. You understand what I say, no? You don't.
Understand.
Okay, nah. Okay, number 17. Okay, same lah. You make a note here. First diagram is daytime. Second diagram is night. Daytime, the sound go up. Nighttime, the sound go down. So, what is the answer? You don't. 17, what is the answer?
C.
Huh?
C.
C. Okay, let's see. Yes, correct. The answer is C, refraction. When the sound changes direction, bend like that, so it's called refraction. You all must know one, oh. Okay. All right, 17 done. Number 18. Which of the following is true regarding the refraction of sound? You read ABC, see which one is correct. Which are the following true regarding the refraction of sound wave? So which one is the answer? Kong Fan Sin, which one is correct? Regarding refraction, which one?
Not
Never
sure.
mind, don't move. Yeah?
Not sure.
Not sure, never mind, Lord, just tell me. If wrong, never mind. Which
D,
one is? C.
D, D.
Boy,
D.
Okay. No, A, B not answer.
D.
Donkey,
Yeah.
yeah. Yes, correct. The answer is donkey. Okay. At night, sound can heard over considerably longer distance. This is correct. Nighttime, the sound from a further distance you can hear because the sound basically go up and then it bend down. So you from far, right, you still can hear at night. Okay. Okay, number 19. Figure shows successive wavefronts of water traveling on surface of water on ripple tank. Perspective plate. Okay, you see the diagram. I let you see first. Okay, so you can see here now. This here the wavelength lambda bigger. Here is bigger, no. Then here the lambda becomes smaller. Not only that, and then you notice the water wave start to bend, refract, bend already. So meaning that here must be deep water, Lor. Then you put a piece of glass inside the water to make it shallower. When the water shallow, right? So the lambda becomes smaller, so the wave will change direction. So first question, drawing a straight line to mark the boundary of the perspective plate. So it must be here. You choose all this line where the line start to bend. So here, here. You see the line start to bend, isn't it? So you just draw a line. So this will be the boundary of the perspective plate. So meaning that start from here is shallow. Here water is deep. So you draw this line. Understand? Yeah. Ram, understand or not? Ram? Quan Xuan, Lau Quan Xuan, understand?
Yes.
Understand,
Mm.
Okay. Right. Next question. Determine the wavelength travel over the perspective plate. Before travel over, mean here So what you do is, cannot calculate, you use a ruler to measure the wavelength. So when you measure the lambda wavelength here is 0.6. So the answer is 0.6. Okay. Yeah. Before travel over the perspective, so it's this part. So the wavelength is 0.6. Okay. All right, done. Next, they ask you to calculate the frequency of the wave before travel over the perspective. Before means hit this part. They ask you to find the frequency. So you see here now, you have the wavelength lambda, only wavelength, Then how to find the frequency now? Oh God, see the question got give some information. Speed got given, velocity 40. Okay, meaning that now you have wavelength lambda, you have the velocity 40. Then can you find the frequency? What formula to use? What formula to use to find the frequency? Okay, I think I answer myself lah. Okay, V equal to F lambda. Okay, use this formula lah. V40 lambda 0.6 here. So you can find the frequency, no? So 66.67. Yeah, that one will be the frequency. Understand? You don't
Understand, sir.
understand? Good. Thank you. The rest understand or not? The rest I feel like I'm talking to the wall, Yuan Yi, Chan Yuan Yi, understand? Chan Yuan Yi, no sound. Gong Fan Xin, understand? Gong Fan Xin should be okay lah.
Yes, sir.
Okay, thank you. Chan Yuan Yi said yes. Understand? Su Xin said yes. Thank you. Okay, Next, determine the velocity travel over the perspective plate. Someone asked question. What is that? Zhong Chao Yi already calculated. He said 33.33. Okay, very advanced, Zhong Chao Yi. Let's check your answer. Yes, correct. Your answer is correct. Okay. Just now, the frequency here, 66.67. Then the frequency in the deep and shallow frequency, same one, remember, when the frequency here, 66.67, the frequency here, same. So you can find the speed using same formula. Frequency, take this value, same one. Frequency in the deep, in the shallow, same. Lambda here, 0.5 when you measure smaller. So you get 33.34. Zhong Chao Yi is 33.33. Okay, it's the same, never mind. Okay. So you get this answer now. And next, this one I don't have the answer. Explain why the water propagated from the sea to the beach. The water wave follow the shape of the beach. Why? Last week, I think I'll explain very careful to you all, I hope you all remember lah. Why when the water approaching to the shore or the beach, right, it will follow the shape of the beach there. Why? Definitely is related to refraction because you are studying refraction now, right? So must be refraction now. Okay, basically like this lah. What you need to write in for your answer, you must write, you say, when the water moving towards the beach, right, the water actually moving from deep water to shallow, from deep to shallow. And when moving from deep to shallow, right, two things will change. One is the speed decreases. The speed will decrease. Another one is the wavelength will decrease. Go to shallower beach, the lambda becomes smaller. So you see, speed decreases, wavelength decreases, and most important is when move from deep water to shallow water, so it will refract, understand? So the wave refracted towards the normal. This one you have to memorize all. From deep water to shallow is refract towards the normal. Due to the refraction, right? So the whole water wave start to bend, start to change direction. So slowly it will take up the shape of the fish. So basically, these are all the answer. Can or not? Can you all write it out? Okay, don't worry. Can you find the answer on this paper? You can find the answer on the paper. Can you find it now? Find yourself. You can find the answer is inside the note. Okay? You Tong way to find the answer, You Tong? You Tong You Ling?
Yes, sir.
You Tong. You Tong, you tell me for this answer, way to find? On which page you can see the answer?
Page 30.
30 Okay, let's go to page 30 See whether got or not Yes, correct. 30. Is here? No. This is one. This one very important. Okay. So the answer you can take from here. It is because, start from here. Water wave propagate from deep water to shallow water. So the speed and the wavelength decrease as the wave approach the beach. And hence, water wave refracted towards an okay until here. That's all. That will be your answer. Okay? Write down the answer please. It's here. Here, to hear the rest, no need. Because you are supposed to need to explain why it follow the shape of the beach. So the answer is here, this part only. Yeah. So please understand this answer now. Okay. Chai Ling, understand?
Understand it, sir.
Okay, thank you, Chai Ling. Darren To, understand? Darren. Can understand? Okay, good. Okay, Darren, thank you. So finish, Okay, next one. Go back to the question, Yeah, when talking about this, I have another thing I want to share with you all. Another reason why I want to go back to the center is because online teaching, I don't know why, you all don't want to on your camera one. I cannot see you. If you all agree everybody to on your camera, let me see your face, then will be much better. I can see your face. This one I tried before to ask you all to on the camera, but nobody bother me. Or everyone come in straight away, the microphone, camera all off, hiding behind. You all don't on the camera. So I find it, I don't feel comfortable to teach like that. When the student is hiding behind, cannot see their face, they don't want to on the camera. I know the reason now. Maybe I understand also because maybe data not enough, your internet speed not fast enough, so you don't want to on your camera. I understand. Okay. I don't blame you all. I understand some of you may face problems now when I ask you to on the camera, right? That's why I study of 1 week already. I think I think better. Everyone go back to the center. Okay, fair to everybody lah. Okay. Okay, question 20. if my school student online, I teach my own school student, during the MCO period, I ask them to on camera, they all on one, they're not, because maybe I'm the school teacher, they all scared me lah. When I ask them to on the camera, everybody on the camera, so I can see their faces. My school student lah, okay. Then my tuition student ask them on camera, nobody on. Maybe you're too shy, because you're from different school ma. You're shy, don't want to on like Wu Yu Tong is very shy one, I know. Okay. My school student, they all from the same school, same class, so they don't feel shy, so they on the camera. Okay. Then come question 20. Figure shows a water wave in the ripper tank travel over Perspex plate. Here you see, water travel over Perspex plate. So here becomes shallow. Here water is deep. Because inside water you have piece of Perspex, so make the water here shallow. Right? So you can see here, in the deep water, the lambda is big. When go near to the shallow water, lambda small. And the second diagram show water propagated from the sea to the beach, from sea to the beach. Then also the same. Far from the sea, the water is deep. The lambda is big. When go near to the beach, right, water shallow. Then the lambda also small. So actually two diagrams, they are similar. They are similar, Now answer the question. State the change in wavelength from A to B. From A to B, A to B. So how the wavelength changes?
Decrease.
So, yes, Lao Guan Xuan, very good. So the answer decreases lah. Okay. Decrease. Now you see lambda here to here, decrease ma. Here also same. Go here, decrease. Lambda decreases. Yeah. Second part, compare the depth of water. Okay, same lah. Here deep, here shallow, correct not? So the answer is straightforward now. A deeper than B. Here also same, A deeper than B. Okay. You see, sometimes the SPM question also not so difficult one. It's okay one. If you understand, you can answer one. Okay, next. Name the physical quantity unchained. What is unchained here? What is unchained? That call a boy. I want to find a boy to answer. What is four of them? User, no name, want to know who. RAM. Can you answer RAM? What is the name of physical quantity which is unchained? RAM, what is unchained from here to here, here to here? What is unchained? RAM? Not there. Maybe type, he type. Let's see. Yes, he type. RAM. What is unchained? Chong Chao Yi give the answer already. Chong Chao Yi answer is correct. RAM, can you type your answer? RAM? What is unchanged? From A to B, what is unchanged? Okay, never mind. So Zhong Chao answer is correct. Frequency unchanged. From here to here to here, the frequency never change. So frequency, the one unchanged is frequency. Okay, next, relate your answer A1, A2 to deduce a wave phenomenon. Okay, they ask you to relate. Relate means you put it in a way like relationship here and here. How you put them as a relationship like A1, A2. This one is something to do with the wavelength. B is something to do with the depth. So you should know the relation, right? So what is the answer? I don't have an answer here. So you all write yourself. What answer? delete A1 and A2. Okay. I want to try Juling. Juling, can you try? Juling? Can you try to give answer, Juling?
The deeper the water, the bigger the wavelength.
Yes, very good. Thank you, Juling. The answer. Can you repeat your answer, Juling, that other people hear?
The
The deep-
deeper the water, the bigger the wavelength.
Yes, very short answer. The deeper the water, the bigger the wavelength. That is answer lah. Between the depth and the wavelength, correct not? The deeper the water, the bigger the wavelength. Okay, that one is answer. Okay, the last one, phenomenon, refraction. This one you must know one. Refraction. Okay. Yeah. Sima, understand? Sima?
Yes, sir.
Can I ask Sima? Sima, I want to see you next week. Or are you coming next week?
Yeah, I think so. I come back.
Yeah. All right. So I hope see everybody next week. All right. Next one is a calculation. Water wavelength 1.5 travel with the speed 2. So lambda 1.5, velocity is 2 from the sea to the beach. Velocity of wave reach near the beach. When go near to the beach, shallow already. So the speed decrease to 1.2. From 2.0 drop to 1.2 because slower. Now the question, calculate the frequency. Okay, you have all this information here, right? You have the wavelength, lambda, you have the velocity, so you can find the wave frequency. V equal to F lambda. Velocity 2, lambda 1.5, frequency 1.33. Okay, so you get the answer already lah. Frequency is 1.33. And the next one, they ask you to find the wavelength near the pitch. Near the pitch means near the shallow region. Find the wavelength. So using the same formula, okay, the speed is 1.2 when go near to the pitch, right? It's given in the question 1.2. Frequency is the same. You can use a deep region frequency, shallow region frequency, same one, and find the lambda lah. So you get 0.9. Okay. So okay, understand? Okay. Okay, then last question. Last question is an essay question. You have to learn. You need to take a piece of foolscap paper to answer in foolscap paper. Okay, don't be lazy and all. Take out a piece of paper, write on the paper. Okay, you must write. Okay, don't just sit down there, listen. You won't remember one. Write it down on the piece of paper. If face-to-face the center, I can make sure you have the paper, you write. But now I cannot. Okay, ready with your paper or not? Okay, this one is experiment question. Mean you have to write the experiment report, write the experiment, Okay, SPM question now, you have to do one, cannot escape one. Okay. Someone didn't switch off the mic. I see who, I can hear the sound. Off already, now everybody off. Okay. Figure shows water wave propagated from sea toward the shore. You can see from here. Here water deep, lambda small, big, right? When go near to the shore, shallow water, the lambda becomes small, correct not? The diagram very clear already, Okay, now question A. State one suitable inference. How to give the answer for inference? Right now, right on the paper now, inference. Okay, to write inference, you must use a keyword depends on. What depends on what? When you look at the diagrams, you should know already. What is depends on what? Only two things here. One is the depth of the water. One is a wavelength. So now, who depends on who? So how to write the inference? Juling?
The wavelength of the water depends on the depth of the water.
Yes, very good answer. So please write the answer, everyone. Wavelength of the water wave depends on its depth. That's all. That one is for inference. You only write who depends on who. That's it. Don't need write the relationship one. No. You only write who depends on who for your relation. So remember now, where you must get this question guarantee. I tell you, you need to write one in your paper 3. Practical test. Practical test, they will ask you to write the report. Write the whole thing, write it out. So start with the inference. Okay. The second, state one appropriate hypothesis. How to write hypothesis then? Hypothesis basically you state the relationship relationship between the depth and the wavelength lambda for your hypothesis. Hypothesis means your predicted result. What will be your predicted result? The result you predict one must be here, no? Between the depth and the lambda, what is the relationship? So, like just now, somebody already give the answer, right? You say the deeper the water, the bigger the wavelength. That one will be the hypothesis. Okay? The deeper the water, the larger the wavelength lambda. Okay? That will be your hypothesis. Got it? Chiling, got it or not?
Yes, sir.
Okay, thank you. Okay, now C. With the use of apparatus such as Ripper tank. Very sad, no? They give you one only, no? And other apparatus. Other apparatus means here you have to find yourself. Think of yourself. Describe an experimental framework to test your hypothesis. Okay, And then first one you write aim. How to write the aim? Aim usually use what keyword what keyword to use when you're writing the aim? No or not? Yeah, someone type there. I see what. To investigate. Juling say, very good. Thank you, Juling. Correct. So you write for aim, right now, to investigate the relationship between what and what. To investigate the relationship between what and what, you see your hypothesis. It must be between who and who. To investigate the relationship the wavelength and the depth of water. Okay, it's between the wavelength and the depth. Okay, that will be your aim lah. Yeah. Next one is variable. Variable, I think in lower form you learned already that you must have three, correct not? First one will be your manipulated variable, manipulate. Second one is responding variable. And the third one is fixed variable or constant variable, right? Okay, before you answer variable, you must already know how to do the experiment. You must can imagine already how to set up the experiment. Then only you know who manipulate, who responding, who is fixed, correct not? Okay, actually you already have this experiment in your paper. Okay, okay, now you go back to the paper and see. But I still want you to write on a piece of paper. Understand? Don't be lazy lah. Practice. You need to practice more. So the experiment is here. This is one. Okay. This one. This experiment between the depth and the wavelength this experiment And then your manipulated variable, you see, you manipulate the depth of the water, adjust the depth of the paper. Responding variable is the wavelength. You measure the wavelength. And fixed variable is the frequency. Okay, so take from here. You can take the answer from here. Yeah, variable. Manipulated is depth of the water. Responding is a wavelength. You measure the lambda. And the fixed variable is a frequency. And you must understand how to do the experiment first. You remember or not? Still remember how to do or not? Come, let me explain one more time to you how to do the experiment. Using electric motor. You on the motor vibrate. So this piece of vibrating part will touching the water. So produce a water wave lah. So the water wave come over, go through this Perspex plate. So here water shallow, right? So your focus is on the shallow water. You want to see the lambda here, right? So first you do like this. You make one piece of Perspex plate, one piece only put inside the water, one piece. When you put one piece of Perspex plate here you measure the depth of the water, let's say 10 cm. 10 cm lah. When you put one piece only, so the water depth is 10 cm. I mean the water here is 10 cm deep lah. You on the motor, then you see the lambda. Don't see here, see here on the piece of white paper. Use a stroboscope to see through, see the lambda, you measure the lambda. Okay, so you see the result is like that. First, put one piece of Perspex, then you measure the water, so you get 10 cm. The depth of the water is 10 cm. Then you measure the lambda. Next experiment, you make it shallower. How to make it shallower? You put two pieces of Perspex inside the water. Two pieces now. Two. 1, 2. Two pieces, it will become, then you measure the depth, it become 8 cm, become shallower. Not shallower here, 8. On the motor, then measure the lambda. Then after that, put 3 pieces. When you put 3 pieces, it becomes shallower. 6 cm only now. And you repeat the experiment a few times adding more and more number of pieces of Perspex to make the water shallower. Understand? Yeah. So whatever you take from here, next one is a list of apparatus all here lah. Ripper tank, lamp, motor, wooden bar, power supply, white paper. This one don't need. These two cancel. This one you don't need. Protractor and the reflector don't need. Perspex plate, meter rule, and stroboscope you need. Okay, copy here. Yeah. I just want to ask you lah, what is a function of the stroboscope there? Remember or not? This stroboscope is for what? For what? You don't the stroboscope is for what? You don't?
Freeze the wave.
Yes, to freeze the wave, make the wave appear like stop moving, so that you can easily see and measure. Okay. Yeah. Hardworking student usually they know one, they know what. Actually, to be sincere, I say for good student, online, face to face, also same one. They also can learn one, They can focus. Those good students are online, so they can focus one. Okay, can listen, can focus. But very sad because as a teacher, I cannot just focus into a small group of students. I cannot only teach a good student one, The other student also I need to look after everybody All I have to jaga all the students, to be fair to everybody Okay. Yeah. So next, arrangement apparatus means a diagram Okay, the diagram I don't expect you to draw here. Okay, you draw later, practice, understand? On the piece of foolscap paper, you draw. Now, I tell you to draw, you better follow, understand? Because in the SPM, they also will ask you to draw one. You must learn how to draw the ripple tank. In fact, in your Form 4 syllabus, right, you have some certain experiment which is compulsory one, All the teacher given a list one, which experiment student must write report, must do one. This is one of them So meaning that this diagram you must draw, no choice It may come out in the SPM one, They ask you to draw one, draw the report tank to show how you do the experiment. Okay. So do it later on, okay? So now I want to move into procedure. Procedure, don't follow here. Don't follow this one. Don't follow here. I say you write for procedure. Ready to write? Yeah, first step. The apparatus and material are set up as shown in the diagram. The apparatus and material are set up as shown in the diagram. That one is the first step. The apparatus and material are set up as shown in the diagram. Your diagram must draw properly. Okay? Okay, second point. Second point means you explain how you start the first experiment. So you say one piece of Perspex plate is placed into the water. One piece of Perspex plate is placed into the water. And then you say the depth of water on the Perspex plate. The depth of water on the Perspex plate is measured using a ruler. The depth of water on the Perspex plate is measured by using a ruler. And you put there, the depth of water D equal 10 cm. So you start with 10 cm. The depth of water D equal 10 cm. Yeah. The next one. The electrical motor is switched on. The electrical motor is switched on to produce the water wave. The electrical motor is then turned on to produce a water wave. And the water wave is observed by using a stroboscope. And the water wave is observed by using a stroboscope. You must write that, no. You must say, observe the water wave using stroboscope. Cannot use your eyes to see one, cannot see. Done or not? Next one, you write the wavelength of water wave on the Perspex plate. The wavelength of water wave on the Perspex plate is measured. The wavelength of water wave on the Perspex plate is measured on the white paper, measure on the white paper by using a ruler. Got it or not? Susin, do you got it? Susina,
Yeah, sir.
you got everything or not, Susin?
Yeah, yes, sir.
Okay. Someone asked question. I see what this question. Teacher can repeat. Which one you want me to repeat, Chong Chao Yi? Repeat the whole thing. Which part, Chong Chao Yi? Which point you want me to repeat, Chong Chao Yi? Okay, just now the one. Okay, I can't remember what I say already, no. Susin, can you help me or not? Susin, can you help me to repeat the last point? Susin, Susin, no more the Juling, Juling, help me to repeat the last point, can or not, Juling?
The wavelength on water wave on the Perspex plane is measured on the white paper by using a ruler.
One more time, Juling, can or not? Thank you.
The wavelength on water wave on the Perspex plane is measured on the white paper by using a ruler.
Okay, thank you very much, Juling. First part of the procedure. Like this, those who ask me to repeat one like this, I will upload the video in the YouTube. You go and find the answer, can or not? Because you say first part of procedure, I don't know which one, no? Ram, can you go and find from the video, you can go forward, find the answer. You watch the video to find the answer, Ram, can Okay, come. I want to move on to the last already. The last one is repetition. How to repeat. Okay. Okay. How to repeat means you need to carry out the experiment. How to repeat is like this, Okay, you write like this. Listen carefully, everyone. The experiment is repeated. The experiment is repeated by putting. The experiment is repeated by putting 2 pieces, 3 pieces, 4 pieces, and 5 pieces of Perspex plate into the water. The experiment is repeated by putting 2 pieces, 3 pieces, 4 pieces and 5 pieces of perspex plate into the water. Got it, everybody? Okay. Comma, not finished yet the sentence just now, comma. Got it, okay, comma, after comma, you write this. The depth of water is reduced to, the depth of water is reduced to 8 cm, 6 cm, 4 cm, and 2 cm. Now you can see the table, no? The depth of water is reduced to 8 cm, 6 cm, 4 cm, and 2 cm by adding the number of pieces of perspex to make it shallower. That will be your last step for your procedure. Finish your procedure, finish already. Got it, Okay. After your procedure, right? The next one is tabulate the data. Tabulate data means you prepare a table. So the table like this. Left-hand side is a manipulated variable, depth T cm N8642. This one you can write because this one is manipulated. You control one. The right-hand side is a responding variable. Is wavelength lambda / cm. This one leave it blank. You did not carry out the experiment, so you don't have result yet. Yeah. And the last part is the way to analyze the data. To analyze data means you sketch a graph lah. Responding variable against manipulated variable. So here is depth. Here is wavelength. Don't put the terbalik. No, terbalik is wrong one. No. Here must be responding. The X must be manipulated variable. Okay. So this is the second last part. This is the last part. Okay. And so finish or not, everybody? So I think finish, Darren, finish or not? Darren. Guan Xuan, finish.
Finish, sir.
Okay. Okay, so we have finished, And now come back here a while. So we have finished refraction. So long lesson. You learn a lot of things and then you answer a lot of questions. Okay. That means now the refraction is very important, you know. A lot of things means is very important one. Okay. So our next lesson, this paper I hope you already printed out lah. I shared with you all last week, right? Okay, come let's see the paper. Next lesson after this lesson the rest I will give the paper to you all. Okay, when you go back to the center, I will follow step and then given the paper to you. You don't need to print anymore. Okay, next one is another new thing you are going to learn. One okay, it's here. Diffraction. What is diffraction? Oh, sorry. Okay, analyzing diffraction of wave. Class, you see in this lesson, first you start with reflection, FLEC, reflection. Then followed by refraction, which you have just finished, refraction. And this is the third one is diffraction. Okay, diffract, DIFFRAC, diffraction of wave. What is the meaning of diffraction? Okay, don't worry, I will explain to you slowly. You all listen now. Let's look at this diagram. On top here, this diagram first. When you look at this diagram, you see the water wave is moving from left, go to right, is moving. The water wave moving, right? And then you put something here to block the water, you know. But you did not totally block it. You allow the water to go through a gap. This is a gap, a small hole. But we don't call gap, you know. Actually, in physics, we call it aperture. So please write it down. Gap. Physics, we don't say gap. We say aperture. Aperture means this small hole. Okay, now you see. When the water passes through a small aperture, a small hole. So what happened to the water wave is spread out. You see, it's spread out, you know, spread out. Okay, it's spread out very big angle. And then the shape are changed to curve shape. Okay, and this is called diffraction. Diffract means the wave gets spread out after it passes through a gap or passes through an aperture. When the water wave passes through an aperture, it gets spread out. So that is called diffract. Diffract means spread out. Okay? Understand? Sima, understand?
Understand, sir.
Understand? That is called diffraction, you know, diffraction. Okay, now you look at the diagram. For diffraction, right, the lambda never change one. You see the lambda before and the lambda after remain the same. We won't change one, no, lambda never change one. Later on, we see what will change, what will not change. Okay, I want to explain to you another method of diffraction. You see the next diagram. Okay, when you put just one piece of the obstacle here, this is also diffraction, you know, but the diffraction pattern is different. So when you see the water wave come over, hit this obstacle, right? So only this part has no water wave because cannot block already. So here no wave lah, this part. Then here the wave can go through as usual, but at the corner there you bend a little bit, bend a little bit, and then get longer, then back to normal. Okay, the wave are getting longer and longer, but it's slightly bend, or we don't say bend, no, it's slightly diffracted. This is called diffracted, you know. Okay, and then it back to normal. Okay, so this is also diffraction. Okay, so diffraction can happen when the water pass through a gap, pass through an aperture, or when the water round over an obstacle. This is called round over obstacle. This is obstacle, so you round over, not pass through, it's round over an obstacle. Okay. So what happened? What you see here? Yeah. So basically, after diffraction, right, wavelength lambda unchanged. Copy, lambda never change. So lambda here, same. Frequency also unchanged. As I told you earlier, frequency never change. And the speed also unchanged. The speed here, the speed here, speed here, same. So remember, three things never change. Wavelength lambda never change, frequency never change, the speed never change. Okay, the one will change are direction changes. Direction change, you see, go like, then after change direction like that. Correct not? This one also, the direction changes. Okay, and the shape changes. The shape, you see, straight line now become curve. This one straight line now got curve a little bit here. So the shape changes. And last one is amplitude decreases. After diffraction, right? The amplitude decreases. Amplitude referring to the height of the wavelength. You see here. At first, the wave, the amplitude is here. Amplitude very big one. This is the obstacle. When it pass through the gap, you see the amplitude becomes smaller. Happen one, amplitude becomes smaller. Okay. Remember that, after diffraction, the amplitude becomes smaller. Now you see this graph show already. Okay, can you take down all these things? Come, copy down. Who is a user lah? You never off your mic, I can hear what you say, user. Now you off. I off for you lah, but I don't know your name, you put the user only. Okay, finish copy or not? Okay, finish. Juling, finish or not? Quan Chuan, finish.
Finish this, sir.
Lao Quan Chuan.
Finish.
Okay,
Finish.
okay, come, we move on. Okay, next one. I want you to see another thing. You see this diagram and this diagram. You see any different or not? The blue color one and the black color one, any different? This first diagram and this one second diagram. Okay, got different, isn't it? You see here are curve, but this one are not curve, you know. Why like that, eh? Okay, listen, diffraction got degree one, you know. You see, when the aperture, the hole, the gap is small. When the gap is very small, so the diffraction is very strong. Curve shape means the diffraction is very obvious, very strong diffraction. Okay, you see like this now. When the wavelength are bigger than the aperture A, this gap A aperture. See lambda bigger than aperture, right? So the diffraction is obvious, or you say strong diffraction. So it's curve shape, so it's strong. Then the second diagram you see here, the gap is very big. The aperture is very big. This one diffraction, but not strong. In this case, actually the lambda here smaller than the A, smaller than the aperture. So this diffraction is not obvious. So not obvious means it's still straight line, but only slightly curved near the edge. Near the edge, it gets slightly curved lah. And it only spread to a small angle. You see, this one spread to a bigger angle. So you see a difference or not? So remember now, the degree of diffraction is depends on the size of the aperture. Okay, the size small, good diffraction. When the size of the aperture big, no good. No good for diffraction. Okay, Okay, come you read the notes now. Okay, what is diffraction? Please follow here. Highlight the splitting of wave as they pass through an aperture around the edge of a barrier. Barrier means the obstacle. First two lines the definition. Is a splitting of the wave as they pass through the aperture or round over the edge of a barrier. The next, the amount of wave bands depends on the size of the aperture or the obstacle barrier. Depends on the size. I like the smaller the aperture, the more the wave bands. Okay, the smaller the aperture, the more the wave band means it diffracted more lah. More obvious diffraction. Okay, so put down here. The more the wave band means more obvious diffraction. Okay. When diffraction happen, okay, the wavelength, frequency, speed do not change. That's I told you already. You already copy down. But the amplitude will decrease. The amplitude decreases. The direction of propagation, the direction changes, and the pattern also change. Understand? From straight line become curve, it changes, isn't it? Okay, all these okay, go and digest it. Read one more time. Read one more time to understand all this. Okay, I'll give you about 2-3 minutes to read. Later on, I'll ask you question. Everything now. Okay, all these things later, I'll ask you question. Okay, all this, everything. Okay, finish. Okay, okay, when I call your name, so you try your best to answer lah, Jinny Hong, are you there? Jinny Hong, Chua Wen, are you there? Chua Wen, are you there? Chua Wen, Chua Wen, you answer okay? You type. You cannot talk. Never mind. You type. Okay, Chua Wen, can you tell me what is the meaning of diffraction? Diffraction is what? Can you type it out? Diffraction is what? Chua? Diffraction is what? Type the answer, Chua. What is diffraction? Got the answer already or not? Okay, I ask another one to type. I see her answer now. One answer like this. Spreading of wave as a pass through an aperture around the edge of barrier. Yes, correct. That is the answer, Chuawen. Thank you. Yeah. So that one is a meaning of diffraction. Next question. What are the things remains the same after diffraction? What are the things remains the same after diffraction? I think very simple, right? Very fast, you should answer already. What are the things remains the same after diffraction? Shi Qi, are you there?
Yes, sir.
Can you answer what are the things remains the same after diffraction?
Wavelength, frequency, and speed.
Yes, correct. Very good. Wavelength, frequency, the speed remains the same. Okay, thank you. Next. What are the things will change after diffraction? This question very simple. What are the things will change after diffraction? Sima, please answer. Sima. What are the things will change after diffraction? Sima.
Shape, amplitude decreases, direction of propagation
Yes, very
changes.
good. Very good answer. Okay, the shape changes, the amplitude decreases, and one more you say is what? Is a direction. You say direction. Yes, direction changes. Okay, good. Thank you. Next one. Next question. When the diffraction is obvious, when the diffraction is obvious, when the diffraction is obvious. Lao Yixin, are you there? Lao Yixin, okay, Lao Yixin, you type, you cannot talk, you type, okay? Lao Yixin, when the diffraction is obvious, when is obvious? Can you type the answer, Lao Yixin? Okay, let me see what you type. When aperture is small, yes, correct, very good. Okay, thank you. When the aperture is small, okay. And next question, when the diffraction is not obvious, not obvious. REM, when the diffraction is not obvious? Ram, can you answer? Okay, let's see. Answer, Ram. When the diffraction is not obvious. Ram, can you answer? Not obvious or when the diffraction is not obvious, when? Answer already? When the aperture is big. Yes, correct. Ram, thank you. When the aperture is big, means diffraction not obvious one. Okay. And next one. Last question I want to ask. Okay. After diffraction, right? Why the amplitude decreases? I did not explain this one just now. I purposely want to explain, and now I want to ask you. I want you all to think more. Why after diffraction, the amplitude decreases? Why? What is the reason? What is the reason after diffraction, the amplitude becomes smaller? Why? With hard question now. Okay, now I ask. So many of you here very smart one. Chai-Ling, you know or not, Chai-Ling? Chai-Ling, why the amplitude will decrease after diffraction? Chai-Ling?
Mm,
Chai-Ling not
the
there. Now, Chai-Ling, why?
the
Why diffraction?
direction change.
No, it's not the reason. Why the amplitude becomes small when after diffraction? It's not the
I don't
direction.
know.
You don't know.
I
Okay,
don't
now
know.
mind. Thank you. Good try, nah. Okay, someone answer already. Let me see who answer, nah. User answer. This user lah. Who are you? I don't know. Spread to larger area. He said spread to larger area. Yes, I can accept this answer. User lah. Can you tell me your name or not? Your answer is correct. Spread to larger area. Who are you? Can you show me your name? Just type your name lah, can or not? So secretive one, no? Cannot let people know the name one, okay? There are 4 users here, just like I noticed. No name one. Okay, maybe too shy lah, Okay, yes, the answer is correct. You say now, after diffraction, the wave will spread out. It spread out to a bigger area, no? When it spread out means the energy also spread out. So the energy lesser energy after it spread out. So once the energy less, Sima, you show your face. Good lah, show lah. Don't need to close the camera. Okay? So it spread out, so the energy become less. Once the energy less, so the amplitude decreases. No? So the reason come from the spread bigger area, right? So the energy spread bigger, so the energy become less. So when less energy, the amplitude decreases. Okay, please make note. Okay. User, still do want to let me know who are you? Very secretive or cannot let me know. How many user there? Just now got 4, now still 1, 2 user. Still got 2 name, no name one, just user only. 1, 2, 3. 3 user there. Just now 4, now 3. Got 1 user that name come out already. I don't know lah. Maybe it's your father, mother also. I don't know. I'm talking a lot of rubbish here. Suddenly your father, mother sit down there. You don't? Yeah. Okay. Next one is diagram lah. Okay. These 2 diagrams you can draw at the same time lah. I already explained these 2 diagrams. Okay, the first diagram you can see, right? The aperture big, lambda small. You see lambda smaller than the aperture. So not obvious lah. Not obvious means it remains straight, but only slightly curved near the edge. So you draw the diagram, make sure the lambda here, same. Okay. And the angle of spread is smaller compared to this. This one, the aperture small, so diffraction is very obvious. Obvious means you spread bigger area, then the shape also become curved. Okay, you see the angle, angle spread become bigger. Understand? Okay, take down these two diagrams. These two are for one, not obvious diffraction. This one is obvious diffraction, or we say weak diffraction. This one strong diffraction. Okay, finish or not? Okay, come on, we move on. Okay, next one. Next, this diagram. This diagram means this is a obstacle, or we say this is a barrier. Actually, the answer already I show you just now is the same as this one. Okay, this one we can take from this answer. Okay, so only this part has no water wave because blocked already. So here straight line, because this barrier is considered big, big. Big means it's like a gap big so the diffraction is not obvious. So it's straight line, only at the corner there, the bend. Okay, getting longer, and then back to normal. Okay, draw this diagram. Yeah, this one finish, huh? Okay, next diagram. Next is the obstacle is small. Now you see the difference. Small obstacle, this one small obstacle, right? So it's more obvious lah. So only this part has no water wave. This one block. So here spread to two. No, one is on the left, one is on the right. So it's spread here lah. Okay. So here curve, getting closer and closer, then back to normal. So lambda remains the same. Okay. So this is diffraction because of small obstacle. Okay, finished. Yeah. Okay, now we still got a little bit of time. I want you to answer some of the tutorial question. Can you turn to the question at the back? Tutorial question, Tutorial 5, okay? Can you start answer the question now? Question number 1. Which of the following figure true to show the diffraction? This diagram is correct. Which diagram is correct, eh? Which diagram is correct? Okay, someone answer, someone volunteer to answer. User again, but this user never tell me who are you. The answer B. Yes, correct. Your answer is correct. B. The rest all wrong one. Only this one you have just draw this diagram, right? So B lah. Okay. By fraction, Okay. Question number 2. How do the frequency wavelength change when the wave in the ripple tank pass through narrow gap? Pass through narrow gap. Taranto, can you answer? Taranto, you type up the answer. Type. Taran, how do the frequency and the wavelength change when the wave pass through narrow gap in a barrier? How the frequency changes, how the wavelength changes. Taran, Taranto, are you there now? Darren, no sound already. Okay. Xuan. This one Xuan. Who is the Xuan? Xuan. Xuan. Darren to answer already. Your answer B, you say B, Darren. The answer not correct, not B. Darren, can you try one more time? Not B, the answer not B. Xuan, this is Yu Xuan, isn't it? Lim Yu Xuan. Lim Yu Xuan, are you there? Darren, try one more time. You say the answer C. Correct. This time correct already. C. Both unchanged. Frequency never change. Wavelength never change. Remember no, diffraction will not change the wavelength. Okay. Okay, number 3. Number 3, not yet. No, you haven't learned sound, never learned yet. Okay, now I move on to one question. Can you look at question number 8, the structure question number 8? Turn to question number 8. Okay, look at question number 8. Okay, this question. Figure shows a plain water wave passing through a small slit. Now, given a diagram like that, isn't it? This one passing through a small slit or aperture, so it's spread out. This one pass through a small obstacle, so also got diffraction. So now the question, state 2 similarities of the wave pattern. 2 similarities. That means happen here and also can see here 2 similarities. You have to write 2 things they are the same one. So first one is what? I don't have answer, The first answer, similarity. Susin, Susin, can you give the first answer? Susin, where are you? Susin, Kong Fan Sin,
Yes, sir.
Yuling say wavelength unchanged. Yes, correct. Yuling, your first answer is correct. So first similarity, you can say wavelength, the wavelength remains unchanged in both diagrams. The wavelength remains unchanged in both diagrams. Okay. Okay, Fansin, still there or not? Can you give another similarity, Fansin?
The speed do not change.
Can you see the speed? Because the question says observe. Observe means you can only write something where you can see from the diagram one. For example, like just now the answer, wavelength you can see. Even though your answer is correct, but because the word observe, observe means your answer only must write the answer can be seen one. Confusion, understand?
Yes.
So any other thing you can see? Lambda unchanged, the one mentioned already. Any other thing you can see?
Teacher can say they are the diffraction of the water waves.
Similarity or similarity cannot say like that. Similarity, you must talk about the shape, talk about the lambda, all this or talk about the direction, all this, right? The direction got changed in both diagram or not, confusion?
Change.
That one is similarity, correct? That one you can see, right? So you can give the answer. Direction of the wave changes after pass through. Don't use the word diffraction yet, You say after pass through the gap or pass through the aperture. You see the direction of the wave changes. Direction of the wave changes after pass through the gap, pass through the aperture. Yeah. Write down the answer now. Last part B. Relate answer to deduce the relevant physics concept and name the concept. Name the concept, then here only you can say diffraction. That's why I said earlier don't say diffraction. Now only say diffraction. Okay. To go to diffraction, you have to relate first. Relate, you say like this. The water wave spread out. The water wave spread out after pass through a gap or obstacle. The water wave spread out after it passed through a gap or an obstacle, and the concept is diffraction, just like that. And the concept is diffraction. Name the concept, so the concept is diffraction. Okay, got it now? Okay, one more minute, the last one. Okay, this one I think you are very easy. Just draw the diagram, show the diffraction. You see diffraction, the amplitude becomes smaller, isn't it? So here, after pass through the gap, the amplitude becomes smaller. Okay, just do like that. But you fix the gap first, make sure the gap all same. Then only draw the amplitude becomes smaller and smaller. Amplitude decreases. Yeah. And last one, explain your answer. Yeah. Okay, to explain the answer, you just say like that. The amplitude decreases is because the water wave lost energy. The water wave lost energy, that's all. Lost energy already. When it lost energy, the amplitude decreases. Okay, got it? Okay, so I stop here for tonight. Okay. So any question to ask here or not? Anyone want to ask any question here? Nobody ask any question. Thank you, everybody. Thank you very much. Okay, so remember, starting next week, please come to the center, the tuition center for tuition. I will stop the online class already. Okay, because not too effective. I want to see you all face to face. Okay, so take good care of yourself. So I hope to see you next week. Okay, bye-bye. Bye-bye, everyone.
Thank you, sir.
Yeah, bye-bye, bye-bye.
Bye.
Yes, bye-bye. Bye-bye.
Thank you, sir.
Yes, okay, bye-bye. Yes, bye-bye.